In this presentation, we're going to learn about the relationship between temperature, pressure, and volume. Let's find out how. The relationship between pressure, temperature, and volume can be explained using the combined gas law. The combined gas law is a combination of Boyle's gas law, Charles' gas law, and Gay-Lussac's gas laws. The first law we'll look at is Charles's gas law, which states volume is directly proportional to the temperature of a gas. When the temperature increases, the volume increases, and when the temperature decreases, the volume decreases. This happens because as the air temp increases, the molecules start moving faster, which takes up more space. The opposite happens when the temperature drops. The molecules slow down and do not move as much, taking up less volume. An example is a bike tire that looks deflated after the temperature drops outside. The next gas law we'll look at is Boyle's gas law, which states pressure is inversely proportional to the volume. This means when the volume increases, the pressure decreases, and when the volume decreases, the pressure increases. This happens because as the volume decreases, the molecules are pushed closer together, increasing the amount of collisions between the molecules, resulting in higher pressure. The opposite happens when volume is increased. The molecules have more space between each other and collide less, reducing the pressure. An example is a bag of chips expanding on an airplane at high altitude. The air pressure is lower at high altitudes, and because the pressure outside the chip bag decreases, the volume inside the bag of chips increases, causing the bag to expand. The reverse will happen upon landing, and the bag of chips will go back to normal size as the air pressure outside the bag increases. Next, we'll take a look at Gay-Lussac's gas law. The last law we'll take a look at is Gay-Lussac's gas law, which states pressure is directly proportional to temperature when volume is a constant. This means that when volume remains constant and the temperature is increased, the pressure will increase. If the temperature decreases, the pressure decreases. An example is a pressure cooker. When the sealed pressure cooker increases in temperature, the pressure inside the cooker increases. And when the temperature is decreased, the pressure inside the cooker is decreased as well. Now that we have a basic understanding of the gas laws, let's experiment and see the laws in action. For the first experiment, we're going to take an egg and force it into a bottle that has an opening too small to fit the egg. We light a match and place it into the jar. We take the egg and place it over the opening of the jar. Now we watch, and the flame is starting to go out and the egg is sucked into the jar. Let's find out why. Let's talk about why the egg was sucked into the bottle. After we placed the lit match inside the bottle and the egg on top of the opening, the air temperature in the bottle increased, and so did the air pressure inside the bottle. As the pressure in the bottle increased, the egg was lifted, allowing air to escape the bottle, reducing the pressure as the volume of air is no longer constant. The pressure would decrease and the egg would seal the opening again, allowing the pressure to build up and repeat the process, making the egg vibrate until the oxygen in the bottle was depleted and the flame extinguished. After the flame went out, the air temperature in the bottle decreased and the pressure in the bottle decreased to a lower pressure than outside the bottle. The higher pressure outside the bottle pushed the egg into the bottle, and as the egg moved into the bottle, the volume of air in the bottle decreased, and the pressure inside the bottle started to increase. Before long, the egg was completely sucked into the bottle, and now the pressure increased until it was equal to the pressure outside the bottle. In the next experiment, we will get the egg out of the bottle. Let's watch. In this experiment, we're going to do the opposite of the last and shoot the egg out of the bottle. The first step is to place the egg over the opening of the upside down bottle. As the air temperature in the bottle begins to increase, we can see the egg begin to move towards the opening of the bottle. After a short time, the egg is lodged into the opening and we can turn the bottle any direction without the egg falling out of the opening. We can see here that as the temperature increases, the pressure increases. We also see that as the temperature increases, the volume of air increases too. As the pressure increases, the egg moves slowly out of the bottle. Every time the egg moves, the volume of air increases and the pressure in the bottle decreases. When the pressure in the bottle is low enough, the egg stops moving. The air temperature keeps increasing and the process repeats itself until the egg is pushed out of the bottle completely and the pressure inside the bottle is equal to the pressure outside the bottle. If we look at this closer, we can see that when the egg is in the bottle and the bottle is flipped upside down, the egg falls towards the opening of the bottle. We heat up the air inside the bottle and it creates a higher pressure than there is on the outside of the bottle. This higher pressure pushes the egg towards the opening of the bottle until it pops out completely, and then the air pressure is equal on both sides. While this is happening, we can see that the volume of air also increases, and as the egg is moving towards the opening, the volume of air inside the bottle is increasing as well. Every time the egg moves, the volume increases, so the pressure inside the bottle must decrease, but as the air temperature keeps increasing, this will keep increasing the pressure until the egg is completely pushed out, and then the pressure will be the same inside the bottle as it is outside the bottle. In conclusion, these experiments were a useful way to understand the relationship between pressure, temperature, and volume. The first relationship we looked at is between temperature and pressure. Gay-Lussac's gas law states pressure is directly proportional to temperature at a constant volume, similar to how a pressure cooker works. We confirmed this during the first part of the egg-in experiment. When the air temperature in the bottle was increased, the pressure in the bottle increased. Also, when the pressure inside the bottle was greater than the pressure outside the bottle, the egg began to lift, allowing air to escape the bottle. During the egg-in experiment, when the flame extinguished, we saw the pressure in the bottle decrease as the air temperature decreased. This caused a high pressure outside the bottle to push the egg into the bottle. We also saw the relationship between temperature and pressure during the egg-out experiment. While the air temperature inside the bottle was increased, the pressure inside the bottle increased, pushing the egg slowly out of the opening of the bottle. The next relationship we looked at was volume and temperature. Charles' law states that temperature and volume are proportional when pressure is constant. This is the reason why a bike tire will be deflated after a temperature drop. We saw this relationship during the egg-in experiment when the flame was heating the air inside the bottle and the pressure was great enough to lift the egg off the opening of the bottle, allowing the volume of air to increase as some air escaped past the egg. We also saw when the flame went out, the air temperature decreased and the volume of air decreased. During the egg-out experiment, the volume of air increased as the temperature in the bottle increased. We could see this when the egg traveled out of the bottle and the volume of air increased. The last relationship we looked at was pressure and volume. Boyle's law states the volume of a gas is inversely proportional to the pressure. We could see this to be true during the egg-out experiment. As the air pressure in the bottle increased, the egg would move towards the opening of the bottle and as the egg moved, the volume of air in the bottle increased, causing the pressure to decrease until the egg stopped moving or was ejected from the bottle. During the egg-in experiment, we saw that as the egg was pushed into the bottle by the high pressure outside the bottle, the volume of air in the bottle was decreasing, causing lower pressure inside the bottle to increase incrementally until the egg was pushed completely into the bottle and pressure inside the bottle increased to match the higher pressure outside the bottle. I hope this helped you understand the laws that form the combined gas law and explain the relationship between pressure, temperature, and volume. Thanks for watching.